Okay, so we are going to go over the other review activity that we didn't get to in class. Some people wanted a recording of it, so that is about isotopes and atomic mass. So just kind of a reminder of how we look at isotopes, right? Isotopes are always going to be atoms of the same element, but have different numbers of neutrons in their nucleus. So this is just a visual representation of that. This is calcium 40. The 40 here is telling us the mass number. This is mass number, and that is number of neutrons plus number of protons. So it's the two things that take up mass. Therefore, it's a counting number. So that's why we call it mass number. And this number at the bottom is the atomic number. It is the counting number, but it is just number of protons, right? So if we look at these two atoms, calcium 40 and calcium 42, what's different between them? Well, they both have 20 protons in the nucleus. That's what defines it as calcium. So every single calcium atom in the entire universe has 20 protons in it. But look at the neutrons. In calcium 40, we have 20 neutrons. In calcium 42, we have 22 neutrons. So 20 plus 22 is 42. 20 plus 20 is 40. And that's why we call it calcium 40, calcium 42. And then if you look, the other subatomic particle inside of the atom is the electron. Now, electrons have very, very, very minuscule masses, so we don't include them when we look at the mass number. But it does tell us about charge. So we know electrons are negative, and we know protons are positive. So if you look at the number of positive charges and the number of negative charges, you have 20 positives and you have 20 negatives. So basically you have a net charge of 0. So this is a neutral atom. Okay. And in calcium 42, we have 20 protons and we have 20 electrons. So that's a positive 20, a negative 20 for a total of 0. So it's again, a neutral atom. Okay. Well, how many protons are found in calcium 42 and calcium 40? All you have to know is the name, and you go to the periodic table and you see that calcium, every single calcium has 20 protons, right? So how many neutrons are found in calcium 42 and calcium 40? So all you do is you do that. So if this was the symbol, right, 42 and 20, and we had calcium 40 and 20. So if you look at calcium 42, in order to find the number of neutrons, you take that mass number minus the atomic number, right? Because this is number of neutrons plus number of protons, and this is just number of protons. So if we subtract out our number of protons, we're left with neutrons. So our neutrons are equal to, here, we're going to get 22, right? If we subtract here, our number of neutrons is equal to 20. So how many neutrons are in calcium 42? 22. How many in calcium 40? 20. What's the relationship between the number of protons and the number of neutrons in an atom? In a neutral atom, neutral, right, they are equal, right? That's what we showed up here. We said, we looked at number of electrons and number of protons, and we said, okay, 20 and 20. So if you have 20 positives and 20 negatives, you have an equal amount of each. Your charge is 0. Now we're not talking about mass, we're talking just about charge here. Okay, so if those numbers were not equal, then you would have what's called a charged ion. Have that. All right, so based on the information, what is common to all calcium atoms? All neutral calcium, big C, calcium atoms have the same number of protons and electrons. All calcium atoms must have the same number of protons, but if they are neutral, then they also have the same number of electrons. Okay, what could the atomic number Z indicate? So here we're I'll put that over here, X, and then it was A and Z. And I tend to put that little thing in the Z. So what could the atomic number Z indicate? So Z is equal to, it's the bottom number, the atomic number, right? And we said, what is the atomic number? The atomic number is our number of protons. So how is the mass number A, this one, determined? Well, this is just an addition problem, right? It's our number of protons plus our number of neutrons. Okay. So from the information, how would you define isotope? Well, what was the only difference in these two atoms? The only difference is right here, we have 20 neutrons. Right here, we have 22 neutrons. Everything else is the same. So isotopes, let's come down here. Isotopes are what? How would we define that? They're two atoms, right, with the same number of protons. But what else? But different numbers of neutrons, right? So another way you could say that is you have two atoms with the, so you could say two atoms with the same, another way to say same number of protons would be the same atomic number, but different mass numbers, right? Both statements are exactly the same. We're just saying them in different ways. So where are the protons, neutrons, and electrons located in an atom? Protons are and neutrons are found in the nucleus, right? And then electrons are found surrounding the nucleus in what we call the electron cloud. So this little bitty dot right here is the nucleus, and then this whole thing and everything in it is the electron cloud. Okay. What do calcium isotopes have in common? Well, they must have in common same number of protons, right? What do they, how do they differ? In the number of neutrons. So where is most of the mass of the atom? Well, the things that take up mass, that count in a mass number, are our protons and neutrons. So those are in the nucleus. So it's the nucleus has the most mass of the atom because that's where we have our protons and our neutrons. And both weigh about 1 AMU, whereas the electrons are 1/2000th, right, of an AMU. So much, much smaller. Okay. So for each of these isotopes, what they want us to do is find the number of protons, neutrons, electrons. Protons is really simple. Down here is the atomic number, that's the number of protons. Same thing. Down here was our number of protons. So now to find neutrons, what we have to do is the top number here minus the bottom number. So 18 minus 9 is 9. 19 minus 9 is 10. And then electrons, if you do not see a charge, you don't see a negative or a positive over here, right here, if you don't see anything there, it's neutral. And therefore the protons and electrons must be equal. Okay. All right. So now here's another kind of isotope, right? Because we see that these are calcium, and because they're calcium, they have 20 protons. But we know they're isotopes because what's the mass number? The mass number is different, right? So here we have, this is our 20 protons. So how many neutrons do we have? We do 40 minus 20. We have 20 neutrons, right? Now down here, we do 42 minus 20. We get 22 neutrons. So this is really similar to what we saw earlier. These are protons, but there's something else different about these. So you're going to look here, has something to do with this. So if we look in these electron clouds, we only have 18 electrons, but we have 20 protons. So we have a positive 20, a negative 18. So positive 20 minus 18 is equal to positive 2. And that is where the charge there comes from. Same thing here. We have 20 protons and 18 electrons. So 20 positive charges, 18 negative charges, we get a charge of +2. And that's why that's written here. Okay, so let's go answer some questions about this. What distinguishes a neutral atom? That was model 1. If I scroll up, this is model 1 from a ion, which is model 2. So these are examples of ions. So what distinguishes the two? The feature that changed between the two is the number of electrons, right? So the ions are different, because they're charged. They're charged due to a difference in the number of protons and electrons, right? So if you have more or less electrons than you do protons, then you're going to have an ion. So based on both isotopes of atoms and ions, what does the atomic number Z indicate? So remember, that was our symbol over here. X is X, A, and Z. So it's still number of protons. That hasn't changed. So how's the charge on an ion determined? It is the difference between the number of protons and number of electrons, right? So if there are more protons than electrons, it's going to be a positive ion. If there are more electrons than protons, then the ion is going to be negative. That's it. So if neutrons do not possess a charge, what is the charge associated with proton? It's positive. What is the charge associated with an electron? It is negative, right? What do the two calcium isotopes have in common, and how do they differ? Well, both, let's talk about common first. Both of them have the same number of protons, right? And we're talking about comparing these two with one another. So compare calcium 40 to calcium 42. So in this case, they have the same number of protons. That's right here. They have the same number of protons, 20. What else do they have in common? The same number of electrons, because they have the same charge. And same number of protons and same number of electrons. Okay. What do they have different? Well, they're isotopes. So of course they have different numbers of neutrons, right? Pretty easy. Okay, so based on models 1 and 2, what would all nitrogen atoms and ions have in common? Well, they all have to have, doesn't matter, they all have to have the same number of protons, right? It's all nitrogen, so it has to be the same number of protons. But because we said atoms and ions, we can't say electrons. So what would all hydrogen atoms have in common? Oh, guess what? Same number of protons. How many protons, neutrons, and electrons are there in one atom of hydrogen 1 ion? So that's this. So what this is telling us, right, is that here, this one, you can't just have one neutron. You can't. You have to have at least a proton or you're not an atom. So that one has to be a proton. You could write it this way as well, but because 1 minus 1 would be 0 neutrons. But sometimes when they're writing this notation, they leave this atomic number off because you can go to the periodic table and go get it, right? So how many protons, neutrons, and electrons are there in one atom of hydrogen 1 ion, right? Because it's charged. So this would be 1 proton. It would be 0 neutrons. Now it's charged, right? It has a +1 charge. So if we have 1 proton, so that means we have a +1 charge, and then we have to add or subtract something, whatever that is, and we have to get a charge of +1, right? So +1 plus something is +1, 0, right? So we have no electrons. I'm going to pause the recording and come back. Hold on. Okay. Here we go, part 2 of our video. So for the following isotopes determine the number of protons, neutrons, and electrons. So remember, protons is always going to be this number right here. So that's going to be 13. This is going to be 17. Our neutrons, 27 minus 13 should be 14. 37 minus 17 should be 20. Now the last one that's just a little bit tricky is the charge, right? So for this first one, we need a charge of +3. So we know that we have 13 positive charges. So then how many negative charges do we need in order to balance that, that number out, right? So what you're going to end up with are 10 negatively charged electrons instead of 13, because, right, a positive 13 and a negative 10 give you a positive 3. Chlorine, we're going to want a -1. So we have a positive 17. So we need one more negative charge. So that's going to be -18, right? Okay. All right. Provide symbolic notation for the atoms or ions with the following. So when you do this, let's see if I can zoom in, make it a little easier. The number of protons in this column is always going to tell you what element it is. So you go to the periodic table, you find one that has 3 protons, that should be lithium. The 3 always goes at the bottom. Then the number that goes at the top is these two numbers added together, the protons plus the neutrons. That gives you 7. And then if you have a charge, you would look at electrons to protons. Here they're equal. You have +3, you have a -3, which gives you 0, so you don't write it, right? B, 7 protons. 7 protons is nitrogen, so that's nitrogen 7. You're going to add your protons and your neutrons here and here in order to get your mass number. That is 17. Now you have 7 electrons. We compare here and here. So we have positive 7, and we have -7. That gives me 0, so I don't have to write anything else. C is 3 protons and 4 neutrons. So 3 protons is still lithium, right? Just like it was in A. We put a 3. We're going to add them together. 3 plus 4 is 7. That gives us our mass number. Now, here's the big deal. We only have 2 electrons. So that's 2 negative charges and 3 positive charges. So that gives me a difference of +1. So I'm going to put a plus. You don't have to put the 1. It's like balancing equations. You don't have to write it. All right, the next one. 15 protons. Who has 15 protons? Phosphorus, 15. And then we're going to add 15 plus 16. And we're going to get 31. And we're going to look and we're going to say we have equal numbers of protons and electrons. So it's uncharged. Okay, 9 protons. 9 protons is fluorine. Fluorine, 9 down there. We're going to add our protons and our neutrons. We're going to get 19. Oh, look at this. We have 10 electrons and only 9 protons. So that's a +9 and a -10 for a difference of -1. So you put a negative, you don't have to put the 1. Okay. The next one, 15 protons. 15 protons, it's just like D. Phosphorus, 15. 15 plus 16, oh, same number, 31. But here we have 18 electrons and only 15 protons. So that's a +15, a -18. So the difference there is a -3. So you're going to put a negative, but usually we put the number, then the charge. I kind of should scooch that over. So a 3 minus instead of -3. It's just the notation that chemists use. Okay, 26 protons. 26 protons is Fe, iron. So we have 26, and then 26 plus 30 is going to give us 56. And then we're going to look, oh, we have a difference here. We have a difference in our electrons and our protons. So we're going to have a plus 26 and a minus 24, which gives us a difference of plus 2, but we're going to write that as 2 plus, right? Because that's the way we do it. Okay. The last one is 46, so that's palladium, PD. And we have 46, and we're going to do 46 plus 60, and that's going to give us 106. But we're going to look, we're going to say we have equal numbers of protons and electrons, so we are uncharged. Okay, not too bad. Okay, provide the numbers of protons, neutrons, and electrons for each of the following atoms or ions. So we'll just do a little table. Protons, neutrons, electrons, right? And I'll just draw, see if I can do this for all of them at once. D. Yeah, there we go. And then we'll just kind of fill it in, right? Okay, I'm gonna pick a different color, make it a little easier. All right, so for this first one, protons is gonna be 47. I don't see anything here, there's nothing there. So what I can say is my protons are equal to my electrons, so that should also be 47. Neutrons is 108 minus 47, 61. PB, lead, so this should be 82. There's no charge, so this is 82. And then 207 minus 82 should give you 125. C, oxygen. Oh, look, I'm charged. I've got to pay attention. Okay, so that gives me 8 protons. Now, if I have -2, I have +8, I have negative something, and that must equal to -2. So what do I have to have here? This must be a -10, right? So this is a 10 electrons, and then 18 plus 8, 6, 26, right? Okay. D, magnesium 2 plus. So my number of protons is 12. So if I have 12 positive charges, I have some negative charges, not sure what they are, I get a +2. What do I have for negative charges? 10. Okay. And then 24 plus 12 is 36. Okay. All right. Same thing, protons, neutrons, and electrons for each of the following. So we'll do this again. Protons, neutrons, electrons. Make our little table. Okay, so nitrogen 7 protons. There's no charge, so that's a 7. 15 minus 7 should be 8. Okay, aluminum. Here we have 13 protons. There's no charge, so 13 electrons. Neutrons should be 27 minus 13, gives you 14. Okay, sodium, oh, it's a charged ion. So we have 11 positively charged protons. We have some electrons, not sure what they are. And we get a charge of +1. So that means we have one more proton than electron. So I must have 10 electrons. 23 minus 11 should give you 12. And that one's good. Okay, oh, bromine's charged. So we have 35 protons. So we have 35 positive charges. We have some number of negative charges, and we get a -1, which means that we must have 36 negative charges. So 36 electrons. So 80 plus 35 gives you, no, 80 plus, 80 minus 35 gives you 45. Okay. All right. Part 2, distinguishing mass numbers and atomic numbers. All right. So, this is a little activity that you do in class, but we're not in class. So we're just going to kind of skip it, and we're going to talk about atomic mass. So basically, if you're looking at the atomic mass on the periodic table, So that this number down here, what you should notice is that it's not a whole number, right? It's a decimal. The number at the top, the atomic number, is a whole number because it's a counting number. We count 6 protons, 7 protons, 8 protons, whatever it is, it's a counting number. But the atomic mass is an average. It's actually the weighted average atomic mass of all the carbon atoms on the entire planet. So not all carbon atoms have the same number of neutrons, right? That's what we just said. So therefore, the average atomic mass is not going to be perfectly 12. Some of them, if you have carbon 6, right? If you have carbon 6, if you have carbon 12, right? What is that telling me? That's telling me that I have 6 protons and I have 6 neutrons, right? That's my protons, that's my neutrons, so I get mass number. So the mass, the atomic mass of a carbon 12 atom is 12 AMU, but we have carbon 12, we have carbon 13, we have carbon 14, and those have more and more neutrons, right? So if we do carbon 13, we still have 6 protons, but that's going to give us 7 neutrons. Carbon 14, we're still going to have 6 protons, so that's going to give us 8 neutrons, right? So what we know is that this mass, this weighted atomic mass, is the weighted average of all of the isotopes, of the atomic mass of all of the isotopes. So if you're looking at what the atomic mass is going to be, it's actually going to be, right, these are the parts that give off mass, protons and neutrons. It's going to be somewhere in this range of numbers. And if you look at that number, just by looking at it, it's 12.01. That means that most of the atoms on planet Earth are carbon 12 atoms, you know? It's the average is a little bit over 12, but not that much. So only a few of them are carbon 13 and carbon 14. Okay, so let's answer some questions about that. Copper has 2 naturally occurring isotopes, copper 63, copper 65. Based on the atomic mass, which of these is more prevalent? So you have to go and you have to look, and if you look at copper, copper has an atomic mass of 63.55. So I have copper 63 and copper 65. That average atomic mass is closer to which isotope mass? It's closer to copper 63. So based on the periodic table, right, copper 63 is more abundant because the atomic mass is closer to that mass number. And that's all you have to be able to do. You don't have to calculate it, nothing like that. You just have to kind of understand it. So let's look at a few other ones. Here we have hydrogen 1, right? So we know how many protons, that's the bottom number, 1. How many neutrons? If you have a mass number of 1 and an atomic number of 1, 1 minus 1 is 0. So how many neutrons? I got none. Number of electrons, well, it's not charged, so I must have equal. So what's my mass number? My mass number is 1. What's the atomic mass of the element? 1.008, right? Okay, next one. Number of protons, 12. Who has 12 protons? Magnesium has 12 protons. Number of neutrons, 12. Well, if it's magnesium, it has to have a 12 at the bottom. And if my number of neutrons is the same, to get mass number, I do 12 plus 12, I get 24. But I only have 10 electrons. So I have 12 positive charges, 10 negative charges. So then what's my difference? My difference is a +2. So last thing is, what's my mass number? My mass number is protons plus neutrons, 24. I look at my atomic mass, it's 24.31. So it's not perfectly 24, it's 24.31 because we have some other isotopes that have greater masses, right? Beryllium here. What's my number of protons? 4, just like this. Number of neutrons, 5. Total number of electrons. It's not charged, therefore we must have equal numbers of protons and electrons. Mass number is going to be the number of protons and neutrons, so that's 9. Go look on your periodic table. Average atomic mass is 9.12. So that gives you an idea that that's why the atomic mass is close to the mass number, but it's not exactly the same. Okay, so what's the difference between mass number and atomic mass, right? When we talk about mass number, we're only talking about an individual isotope. So one individual isotope. It's really just a counting number equal to the number of neutrons, right? It must be a whole number. But when you talk about atomic mass is the average mass of all the isotopes. It's really the average weighted average mass of all the isotopes. So it's usually not a whole number. This one's not a whole. The math worked out perfectly because it is that weighted average. So let's give an example, right? So the mass number for the isotope, we'll do carbon 12, right? So what's our mass number? Number is equal to 12, right? Because that's how many protons and neutrons are there. But in order to get the atomic mass of the element, that you have to go to the periodic table. So we're going to do atomic mass. Okay. So some of the naturally occurring isotopes are different elements. So in this case, we're going to do 10. So how many neutrons are present in each isotope, and then write the symbolic notation for each. I prefer to write the symbolic notation first, and then determine number of neutrons, right? It's really easy. So SN is 10, and all 10 is going to be 50 protons. So then look at your isotope name, mass number, right? And then to get my number of neutrons, all I do is subtract the two and I get neutrons. Yes. Okay. Let's be. Okay. So the next one. The next one is SN. 10, 19. So I'm gonna have 50 protons because it's 10. So difference 119 minus 50. I get neutrons. Have 10 over 20 protons. 124. Always going to be 4 neutrons. Okay. Same thing, but now we're going to do all magnesium, so they must all be 12. Different is their mass. Subtract the two. Based on the average atomic mass given on the period, and your average atomic mass for magnesium is 24.21. Is the most abundant. So I'm going to look for the magnesium that has the mass number closest to it. All right, so now we have two stable isotopes of chlorine based on our atomic mass of chlorine, which if you go to the periodic table, the atomic mass is 35.45, right? Which one is more abundant? 35.45 is closer to 35, so it is chlorine 35 is more abundant. You don't actually have to do the math. You just have to look at the relationship. So now bromine, similar thing. Based on the atomic mass of bromine, we go and look up bromine, Br. We get 79.90. Oh, which one's more abundant? Well, halfway, right? 79.90. We're almost halfway between the two, right? Halfway would be 80. And then that would mean that we have a 50-50 mix. So you're slightly closer to 79, but you have almost a 50-50 ratio. So half bromine 79, half bromine 81. It's slightly more of bromine 79, but they're pretty gosh darn close. Okay, so that ends our isotope activity. Have a great day.